Hydrogen is the most simple chemical element on Earth. As a matter of fact, atoms are composed by a single proton and a single electron. That's why hydrogen is the first element on the periodic table. Many think wrongly that hydrogen is an energy source. However, it is actually an energy vector because it can accumulate and provide that energy. For example, this process happens with fuel cells, which generate electricity using a hydrogen chemical reaction, producing water, heat, and especially electricity as a byproduct. Even though hydrogen is the most abundant chemical substance in the universe, on our planet, it can be produced using several internal resources such as fossil fuels like natural gas and coal, water, nuclear energy, and other renewable energy sources like biomass, wind, solar, and geothermal, and a wide array of processes. Hydrogen can be produced at or near the point of use, in larger facilities and then delivered to the point of use, in intermediate-sized facilities located close proximity, usually from 25 to 100 miles, to the point of use. Hydrogen can be produced using several different processes. Thermochemical processes use heat and chemical reactions to release hydrogen from organic materials like fossil fuels and biomass. Water can be split into hydrogen and oxygen by electrolytic processes or by solar energy through photoelectric processes. Microorganisms such as bacteria and algae can produce hydrogen through biological processes. Let's see the most common technologies for hydrogen production for each process. Thermochemical processes, as the name says, use heat and chemical reactions to extract hydrogen from molecular structure of natural gas, coal, biomass, and even water. Natural gas reforming is the most commonly used method for hydrogen production, and the reaction is made with hydrocarbons like methane. Natural gas contains methane that can be used to produce hydrogen by thermochemical processes like steam reforming and partial oxidation. In the steam reforming, the methane and other hydrocarbons react with high-temperature steam under pressure, and in the presence of a catalyst, the reaction is accelerated. The reaction products are hydrogen and carbon monoxide. The steam reforming process is endothermic. That means heat must be used to the process for the reaction to proceed, usually burning part of the methane. In partial oxidation instead, methane reacts with a limited amount of oxygen, which is not sufficient to completely oxidize the hydrocarbons to carbon dioxide and water. The reaction products are always hydrogen and carbon monoxide, but as you can see in the chemical reactions, the partial oxidation produces less hydrogen with the same amount of fuel that is obtained by steam reforming. However, partial oxidation of methane is an exothermic process, which means it gives heat. That's why it's much faster than steam reforming. Subsequently, in both processes, carbon monoxide and steam react together with a catalyst in the so-called water-gas shift reaction, producing carbon dioxide and more hydrogen. In the final step of the process, called pressure swing absorption, carbon dioxide is removed, leaving pure hydrogen as a result. Let's talk about electrolytic processes, where electricity is used to make chemical reactions. The most common process is electrolysis of water, where water is split into hydrogen and oxygen using electricity. This could be a sustainable method for producing hydrogen because there would be no greenhouse emission during the renewable resources production. In the electrolysis of water, The electrolytic cell is made by an anode and a cathode, and they are split by an electrolyte, as in fuel cells. However, the process taking place inside the latter is the exact opposite. As you can see in this polymer electrolyte membrane, PEM electrolyzer, the electrolyte is made of strong plastic material. Water reacts at the anode to form oxygen, positively charged hydrogen ions, or protons, that move across the polymer electrolyte membrane up to the cathode. Electrons that flow through the external circuit to the cathode like protons. At the cathode, hydrogen ions combine with the electrons from the external circuit to form hydrogen gas. Differently from the electrolytic processes using electricity, photolytic processes use sunlight energy to split water into hydrogen and oxygen. The processes offer long-term potential for sustainable hydrogen production with low environmental impact. In a photoelectrochemical cell, PEC, the semiconductors are similar to those used in photovoltaic solar electricity generation. They are immersed in a water-based electrolyte where sunlight energizes the water-splitting process into hydrogen and oxygen, like in the electrolysis of water. Among biological processes, we can certainly include microbial conversion of biomass to take advantage of the ability of microorganisms to consume and digest biomass and release hydrogen. But how does it actually work? In fermentation-based systems, microorganisms such as bacteria break down organic matter to produce hydrogen. Microbial electrolysis cells, MECs, are devices that harness the energy and protons produced by microbes to produce hydrogen. Let's see how it works. The electrolysis cell is composed by an anode and a cathode. The microbes in the anode consume the organic matter, such as acetic acid, producing electrons and protons. The electrons are passed to an electrode that travel through a wire to the electrode in the cathode section. With the help of a small added voltage, the protons are combined with the electrons to produce hydrogen gas. The so-called green hydrogen is produced from renewable resources. Although a big disadvantage to producing green hydrogen is the huge amount of electricity from renewable resources, the great news is that the prices of clean energy have decreased in recent years. On the other hand, we are facing an increase in prices in fossil fuels. A decrease in reserves and new solutions to fight climate change, air and pollution that have been leading more countries to invest in this technology for sectors like transport, chemical industry, and heavy industry. In a world where 7 billion people are slave to the oil, do you think that green hydrogen will be the most effective clean alternative fossil fuel? Share your opinion with us in the comments.